Hello friends, welcome back. Hearty welcome to you. In the last session, we looked into wavy curve method or method of intervals to find out the solution set of inequations. In this session, we'll try to briefly focus upon modulus of the variable or the modulus function. Then we will see some problems where we have both modulus and method of intervals or wavy curve method combination. So we'll try to solve some problems. Before that, we'll try to understand what is modulus of a variable and how the function is defined. Modulus of, suppose let us say a variable x if we take, then that will be equal to the value of x if x is greater than or equal to 0. When x equal to 0, it is 0, so we can say if it is x greater than or equal to 0. Also, modulus of x is equal to minus x if x is less than 0. So, modulus function always returns positive value only. If it is negative value, we are multiplying again with minus, so we will be always returning the positive value only. This is the definition of the modulus. So, if x is greater than or equal to 0, then the modulus of x will return x. If x is less than 0, then modulus of x will return minus x. Now, that is with respect to, that is the definition of the modulus of a function. Now, let us say modulus of x is equal to a. Then what is the meaning of that? Let's try to understand. Suppose we have been told that modulus of x equal to a. What's the meaning of that? We will take two scenarios. In first case, we will say that x is greater than 0. In the second scenario, or maybe greater than or equal to 0, and in the second scenario, x is less than 0. Now, according to the function whatever we have just gone through, we just understood that if x is greater than or equal to 0, then modulus of x is equal to x only. So, we can write down then, in this case, x equal to a. When we go to the next case, we have x less than 0 here. That means if x is less than 0, modulus of x is given by minus x. So, I will write down minus x equal to a, which is nothing but x equal to minus a. So, if modulus of x equal to a, that means x equal to a or x equal to minus a. Now, this is pretty simple because it's equal to symbol. Now, suppose instead of equal to we have inequation less than or equal to, greater than or equal to, then how the scenario will be? Let's have a look at that. Let us say suppose modulus of x is less than a. Now, what will happen now? What will be the solution set of this? Let's try to understand. Modulus of x is less than a. So, again there are two scenarios as per the definition of the modulus. One, x can be greater than 0 or equal to, another one is x less than 0. If x is greater than or equal to 0, then we know modulus of x is nothing but x only. So, can I say x less than a? If modulus of x value will be minus of x if x is less than 0. When x is less than 0, we know that modulus of x returns minus x. That's what we have seen in the last page. So, we know that modulus of x will be minus x and that is less than 0. So, can I say now minus x is less than 0? Sorry, we are talking about a, right? So, x greater than or, oh sorry, wait a minute. In this case, x is greater than 0, that's a condition. In this case, x less than 0. Now, this will become x less than a, and here it will become minus x less than a. That means x greater than minus a. So, what's the meaning of that? X less than a, x greater than minus a can be written as together minus a less than x less than a. So, whenever you see modulus of x is less than a, that means minus a is less than x less than a, we can write that. Suppose instead of that it is modulus of x is less than or equal to a, then equal to also will come here, minus a less than or equal to x less than or equal to a. I hope this is clear. Let me repeat that. Suppose we have been given that modulus of x is less than a. So two scenarios we have. In one case x is greater than or equal to 0. Another scenario x is less than 0. When x is greater than or equal to 0, we know that modulus of x is already positive, so it will be x only. X is less than a is one condition. When modulus of x, value of modulus of x when x is less than 0 is minus x. Minus x is less than a, that is the second scenario. In this case, I can multiply with minus. You know, whenever I multiply with minus, the sign, the operator will change. Less than will become greater than. So it will become x greater than minus a. We have x less than a, x greater than minus a. We can club them together and we can write down minus a less than x less than a. So whenever you see problems related to modulus of x less than a, immediately you can write down minus a less than x less than a. Or if modulus of x is less than or equal to a, you can write down minus a less than or equal to x less than or equal to a. Now let us see the condition where modulus of x is greater than a. What happens in such scenario? Let us say modulus of x is modulus of x is greater than a. Now we have again two conditions. Let me write it. One is x greater than 0 or equal to 0. Another is x less than 0. In this case, modulus of x will be x only. So I will have x greater than a. In the second case, modulus of x is equal to minus of x. So I will have minus x greater than a. Now can I say this is nothing but my multiplying with minus x less than minus a? So what is the summary we understood? Modulus of x is greater than a. That means x is greater than a or x is less than minus a. Similarly, if modulus of x is greater than or equal to a, then it is x is greater than or equal to a or x is less than or equal to minus a. So the last formula what we learned about modulus x less than a and this formula modulus of x greater than a are very, very important. Those two will play a very critical role when you are solving the problems. So whenever we see modulus of x greater than a, immediately we can write down x greater than a or x less than minus a. How we got this? Because first condition x greater than or equal to 0, we know modulus of x is x only, so x greater than a. In the second condition, modulus of x is nothing but minus x because x is less than 0. That means the value inside is negative, so I have to make it positive, means I should multiply with minus. That's why minus x is greater than a or x is less than minus a. If there is modulus of x greater than or equal to a, then it will become x greater than or equal to a or x less than or equal to minus a. Now let's try to take this to next step little bit and see some more this type of statements. Suppose I have been given modulus of x minus a less than r. What will happen in this scenario? We already know that, so let's think about it. What we know? We know that whenever we have, let us say this whole thing is my x. Now what is this format? What we learned just now, modulus of x less than r. That means what we learned for that, modulus of x less than a minus a less than x less than a are nothing but, can I write down now, minus r less than x minus a, that is my x, less than r. Now we are interested in x value, so we want to add plus a. It will become a minus r less than x less than a plus r. So we know that x will be, if you look at, x will be between a minus r to a plus r, excluding the boundaries. So we can say modulus of x minus a is less than r, then we know that is equal to a minus r less than x less than a plus r. Similarly, modulus of x minus a less than r equal to r, that means we know a minus r less than or equal to x less than or equal to a plus r. Now you can ask me, we already checked for modulus of x minus a less than r. What happens if modulus of x minus a is greater than r? What happens in that scenario? Let's have a look at that scenario and we'll close with that. In the next session we'll start doing problems based on these concepts whatever we learned. Suppose we have now modulus of x minus a is greater than r. Now tell me what will happen. We have two scenarios. In one scenario x minus a is greater than 0, that means x is greater than or equal to a. In the other scenario x minus a is less than 0, that means x is less than a. In the first scenario modulus of x minus a will be x minus a only, so I can say x minus a is greater than r, or nothing but x greater than a plus r. Also here we have now modulus of x minus a is nothing but minus of, so I will have minus x plus a is greater than r, or can I say minus x greater than r minus a, or minus x greater than minus of a minus r, or can I say x less than a minus r. So x is greater than a plus r or x is less than a minus r. This is exactly nothing but what we learned earlier. We said that if modulus of x is greater than a, then we know that x is greater than a or x is less than minus a. Now what happened to x? X became x minus a and a is r. So one will be x minus a greater than r. Another will be x minus a less than minus r. So in this case it will become x less than a minus r. In this case it will become x greater than a plus r. That is x. Let me just, this is, so you can do that way too, whatever we just learned. X greater than a plus r or x less than a minus r. If you want to go fundamentals also without looking into what we learned earlier, you can also different cases, two different cases we have, one greater than or equal to a, one less than a. Greater than or equal to a, this will remain as it is. Less than a, this needs to be multiplied with minus. It's pretty simple. So you know that now whenever you see modulus of x minus a greater than r, you know immediately x is between a minus r and a, x is greater than a plus r. So how this one will be? Let's write down that how x is less than a minus r, that means minus infinity to a minus r union x greater than a plus r. So a plus r to again infinity. So this will be the solution set. In the next session what we will do, we'll start doing simple examples based on these concepts whatever we learn, and we will also see some problems where we combine this modulus of a variable with the wavy curve method whatever we learned to solve to find out the solution set of linear inequations. Thanks for your time and support. I'll catch you in the next session. We'll continue with this. Till then, keep smiling and sharing. Bye for now.